Hi, this is Roger from Kanka Labs, and today this is the first part in a series to introduce you to a line of digital input-output interfaces. Today and in the following parts we'll talk about the RIST, the relay interface. As you already can see, it has 8 relay outputs. It's cascadable, which means you can put up to 16 devices in a row. It can be directly controlled from a PC over the serial connection or any other device that can talk to, that has a serial port and can transmit over a serial port. But it can also be programmed, which means you put a time sequence inside it consisting of up to 30 steps or 30 patterns. And for each pattern you can give timing length, which is which can be multiples starting from 1/16th of a second up to weeks, so that in the end one sequence can run from 1 second to up to 10 months. So that is quite a big span. And if you use multiple ones in a row, when they are cascaded, they are all synchronized because they have in their connection a common sync line. And starting the sequence can either be done over a PC command or an external command, or you can use it completely standalone once it is programmed by starting the sequence with a push button. You even can start it with an electric signal by simply inserting a transistor which pulls the sync line low. And well, you not only can get it with relays, but also with open collector output in a special version, which means you can drive small DC loads up to 100 milliamps per output, or 500 milliamps max for one output. So it's quite versatile, and it can also be connected to another of our interfaces, the RD30, which has 30 digital inputs. Some of them are digitally isolated with optocouplers. And the last one of our digital input-output devices is the WR64, which has 64 open collector digital outputs, which also can deliver up to 100 milliamps. But let's start with RIST, the relay interface. I'll first of all show you a demo how to program it, and then in the next part of the series I'll explain the hardware and the software. And by the way, you don't have to use the programs that we supply. All the commands are open, which means you can write your own program in whatever language you want, no matter if it's in Windows, in Linux, if it's Visual Basic or .NET, even Pascal and whatever. You can even use a simple terminal program to send commands directly, and it's all fully explained, and well, you can do quite a lot with it. So let's start and take a look at a demo where we just program 2 cascaded devices and look at the sequence and how it all works. So let's start our first programming example with our main program relay.exe. First, I apologize that the designations are all in German. That's because this program was not written by ourselves, but by a friend of ours who is a teacher, and we'll try to let it translate into English, but you'll see that most of the designations are quite clearly, and I'll explain every step. And the second thing is, when you compare the numbering of the relays, which is in the program from 0 to 7, and on the relay interface it's from 1 to 8. We'll also try to change this in a future version of the program, but for this purpose I think it's no problem to get away with this. So first thing we have to do, because our relay interface is connected via a serial port, we have to select the right COM port number. If you don't know the exact COM port number of your PC or your USB serial COM adapter, look into your device manager to find out the correct number. In this case, it's COM port number 1. And now, because we will show an example where we cascade two interfaces, we first have to give each relay interface a separate address. That's why the two relay interfaces are not interconnected at the moment, because for giving them an individual address, of course, you only have to connect one of them. So let's give this relay interface the address number 1. And now it's done. And now we connect the other relay interface with power. And oh, you see there's still an old program loaded. And we'll stop the program. And we give the second relay interface the address number 2, transmit. And now each of them has an individual address number. And now we reconnect the two together with an adapter cable from data out of relay interface 1 to data in at relay interface 2. So, by the way, it doesn't matter if you use the data in or data out port. They are each paralleled internally. Don't worry about that I've connect data out to data out. That doesn't matter in practice. Now let's reconnect the PC over the COM port and reapply power. And well, now let's try out the most simple mode to set the relays. That's the direct mode. For that purpose, we have to use first set an address which relay interface we want to use, and now let's make a pattern of every second relay set on. Press apply, and we see that on relay interface number 1, exactly as in our pattern, every second LED is lighted. Now let's make the opposite pattern on relay interface number 2. And it does exactly what we expected it. It has set the alternate pattern to relay interface number 1. And there is an additional selection, which means all relays. Now, if we want to set all relays to the same state, we just use as address all relays, and as you saw, now both relay interfaces switched all their relays off according to the pattern all off. Now let me in short explain what happens in the background. Whatever command you set by pressing apply or by pressing transmit program, this is only a GUI, a graphical user interface, just to send the right byte commands over the serial COM port to the relay interfaces. So because all the necessary byte commands to program the relay interface are completely and fully documented, you of course can write your own program just to set the relay interface to any state or to program it to every kind of time sequence you want by simply sending byte commands to the right COM port address of your serial adapter or serial COM port. And so that's quite easy. Now, the most interesting part of programming the relay interface is the time-dependent timestamp programming, and this is done in this part of the relay.exe program. Now, let's first of all again select the address of the relay interface we want to program. Here also we have the selection all, but we only want, for a first example, program relay interface number 1. And then here we have the base time unit. We choose this as well. Let's say you can see it runs from 1/16 of a second to 60 minutes. And let's suppose we want the smallest time step, and that way also as the base unit, 1/4 of a second. And now let's try to set one relay after the other with an increasing time step. Now, how is that done? We first of all set all relays to off, and here we insert the pattern that we have here, which at the moment is all off. And you can see now we have this pattern as the first step in our time program. And here we still have a multiplier, which is for our first step still 1, which means the first time step is 1 times 1/4 of a second. Now, the next step shall be to switch on the first relay, and we still keep 1/4 of a second with a multiplier of 1, and we insert this step. Now, we want to switch on the second relay while the first one is turned off, and we want to keep the state double as long, which means a multiplier of 2. So the second state, the next state, or the next time step we are programming will be half a second, because of course 2 times 1/4 of a second is half a second. Now we can again insert this step, and now let's say the next step will have a multiplier of 4, which gives us 1 second. And now let's suppose we make an error. We insert the erroneous time step. Now we can either delete it or we can replace it with the correct one. Now we will replace it, and we choose the correct pattern with only relay number 2 on, and replace it. And as you could see, this time step is replaced, whichever one is just marked at the moment. And as well, if the sequence of time steps is wrong, you can move every marked step sequentially one line up or down. So it's quite flexible to program each step. Now the next step will be relay number 3 with the multiplier of 8. We insert it, and relay number 4 with a multiplier of 16, and so forth. Next relay, multiplier of 32, insert. Relay number 6, multiplier of 64. Now this of course gets quite long, the time steps. And finally relay number 7 with a multiplier. As you can see, we can go up to a multiplier of 255. Here we need 128. And as the last step, we want to have all relays set on for 1 second. And that will be it. Now we have to transfer the time step program. As you can see, you get a confirmation program is transferred. And now we have two possibilities to start this program. We can let it run once, or we can let it run continuously. And we first start with a one-time run. And as you can see, it started with relay, the first relay, which here has the number 1 and here is number 0. And each time step now is progressively longer. We don't have to wait till the end. We can, if we want to stop the sequence, we can simply press stop. If we want to let it run again, we start again, and you see it runs again from the start. Now, to show you or to demonstrate you the continuous run, we will shorten the last time steps a little bit to let's say 1 second. We replace, you see, I've done the wrong pattern, but no problem at all. We just replace it again, and we make this time step also a bit shorter to a duration of 1 second. Replace it. And we also, well, we'll leave the rest, and now we again have to transfer the program. It's done, and now we start continuous run. And it gets longer, and from relay number 6 on it gets shorter again with a 1 second time step, and then everything will repeat again from start. So you see, it does exactly what we have programmed it, and to prove to you that the program remains inside the EEPROM of the relay interface or of the microcontroller, I will pull away the power and reapply it, and we start again. And you see it has kept its program and does again run in continuous mode. Now we stop it, and now let's program another program into the second relay interface with address number 2, and we just reverse the sequence by dragging each line 1 up. It starts with all relays on and then goes backward. And that should be it. Let's again see if everything is right. Yeah, it looks good. Address number 2 is right. We transfer the program, start a single run. So as you could see, now only relay interface number 2 did react. The reason is because we still had address number 2 only and not all. And now, as a last example, I'll show you that both relays are working in sync, but with a completely different pattern and reversed time steps. And of course it's a little bit confusing because we have different time steps and the reversed order. But if you would watch it in slow motion and count the seconds, you would see that it did or does exactly as what we have programmed it to. Now, you don't have to input every time step every time again. Of course, you can store and save the patterns with the ending REL, and the two time patterns that we have programmed are already here pre-programmed, and now we could replace them or give them a new name, and of course we can load them again back or open them again back into the GUI of the relay.exe program. Now, this was the basic demonstration of the main program to interface with the relay interface and with cascaded relay interfaces, and I think it became quite clear how it works. And as a final example, I'll show you how to start a pre-programmed, or in this case two synchronized relay interfaces, how to start them externally without the use of the PC and a interfacing program, because the relay interface does have the capability to be started with either a push button or a transistor switch or a positive 5 volt signal. And for that demonstration I'll have to change the wiring a bit. So that was it for this time again. I hope you liked it. You can of course leave a comment down below, and if it was interesting for you, then give it a thumbs up. And down below you also find, as usual, links to our forum where you can leave questions or suggestions, where you can discuss it with other users. Perhaps you already own a RIST and have an interesting application. Please share it with us. And well, next time we'll explain how it all works, how the connections are made, how the hardware looks like, and how it is programmed. So, bye. See you next time.